Let's take a look at this word problem. 3 people get speeding tickets, Lyle, Mary, and Stuart. We're going to have to figure out how to compare their tickets because each one of them is going a different mile per hour and in a different speed zone. So I think a good way to compare them would be, let's see, Lyle is 10 miles per hour over the speed limit. So he's 10 over. So maybe we can just compare how much they are over to how much their ticket is. So he's 10 miles per hour over and his ticket is 121. Mary is 15 miles per hour over the limit. And her ticket is 151. Stuart is 18 miles an hour over. And his ticket is 169. So what are the two variables? Well, the miles per hour over that you are, that's going to be one of our variables. And the cost of your ticket is your other variable. Also, if you look at the bottom of this sheet on your graph, you can see on the x-axis is miles per hour over the limit, and on the y-axis is cost of the ticket. So now, let's write our ordered pairs. Lyle, his x-coordinate is 10 because he was 10 over the limit, and his y-coordinate is 121 because that was the amount of his ticket. Mary was 15 over, that's the x-coordinate, and her ticket was 151, that's the y-coordinate. Stuart was 18 over, that's his x-coordinate, and 169, and it is his y-coordinate. Let's graph these and take a look at what happens in the graph. So Lyle's point is x-coordinate of 10, y-coordinate of 121. There's Lyle. Mary was 15, 151. And Stuart was 18, 169. So does this look like a linear pattern? To me it does. It looks like these are in a straight line, and we'll talk a little bit about that later. Would they have to be in a straight line? Okay, we'll talk about that after a while. But for now, we have our Lyle, Mary, and Stu all in a line. So let's go back to our problems. Part C, use 2 of the points. Find the slope. Okay, I'm going to pick point 1 as Lyle and point 2 as Mary. So that means the 10 is the x-coordinate of point 1 and 121 is the y-coordinate of point 1, x1 and y1. Point 2 is x2 and y2. I could have done any of these points. I could have done Mary and Stuart. I could have done Lyle and Stuart. I just need 2 points that I know are on my line. So to find the slope, I'm going to use the slope equation. y2 minus y1 over x2 minus x1. It really helps to label the points. Then there's no confusion about which thing goes where. Then work out the arithmetic. Six is our slope. 6 is the m. I could have done this without the slope equation also if I just would have looked, if you will figure out the rise between these 2 points, how far the y-coordinate changes, 30, and then figure out the run, how much the x-coordinate changes between points. You get 30 divided by 5, rise over run, which is 6. Okay, let's find the equation of this line. First, to pick a form, slope-intercept needs the slope and the y-intercept. Point-slope form needs the slope and a point. Since we don't have the y-intercept, I'm going to use point-slope form because that just requires me to have the slope and a point. Oops. When I use point-slope form, I need the slope, which I have, and a point. I'm going to pick point 1, but you could pick any of the points. I'm going to sub out the y1, the m, and the x1, and put the 6, the 10, and the 21 in there. I will leave the y and the x. Those will be the y and the x in my equation. So y1, that's 121. M is 6, my slope. And the x-coordinate of my point is 10. So now let's simplify that. I will distribute. And then I'll get that y by itself, so I'll add 121 to both sides. Negative 60 plus 121, that's a positive 61. And there's the equation to my line. Use your equation to predict the amount of a ticket if the speeder goes 30 miles per hour over the speed limit. Well, here's our equation. Y equals 6x plus 61. Whenever I'm using an equation with y and x, I make myself a little cheat sheet. What are the x's? Well, the x's, down on the x-axis here, is miles per hour over the speed limit. And what are the y's? What are the y-coordinates? What's on the y-axis? That's the cost of my ticket. I do this in problems all the time. Make myself a little cheat sheet. What's what in the equation? So back to the equation. Y equals 6x plus 61. I know the speeder's going 30 miles per hour the speed limit. I want to know the amount of the ticket. So what's the 30? Well, that's miles per hour over the speed limit, so I'm going to put that in instead of the x. So I just plug that into my calculator. 6 times 30 plus 61 is 241. So I know the cost of my ticket is $241, which should match up with our line. If we have a cost of 30, we should have a ticket of about 241-ish. Right about there. You can see that our line would probably go out that far. What is the slope of your equation? What does it mean? Well, our slope is the m number, 6. The slope of a linear equation is always the rate. And when you have a linear equation, you are assuming a constant rate. You're assuming that this ticket is going to go up at the same rate. So 6, let's interpret that a little bit more. 6 what? This is going to be $6 per mile per hour over the speed limit. Okay, $6 per mile per hour over the speed limit. So that means for every 1 mile I go over the speed limit, I'll be spending $6 in the cost of a ticket. Part G. Based on the 3 points that we have been given, Lyle, Mary, and Stu, we have assumed a linear relationship because they were in a line. Does this have to be a linear relationship? A linear relationship means that you have a constant rate. This doesn't have to be a constant rate. Maybe what happens is after 25 miles an hour over the limit, maybe they call you for reckless driving, and maybe that makes the amount of your ticket go way up. So maybe it's linear through here, and then at 25 miles per hour, it goes up more rapidly. That would be a nonlinear relationship. So that's something to think about too. In beginning algebra, we deal only with linear relationships, constant rates. But in the next class, you will deal with problems that have exponential relationships or quadratic relationships.